Alright, so this is gonna be, it's Lorelai Carrillo. This is gonna be my Jedi lesson for week 2B. Today we're going to solve a problem in relationship to the heart. So I thought this would be kind of fun because I'm into this stuff. So the problem says a defibrillator is used during a heart attack to restore the heart to its normal beating pattern. A defibrillator passes 17A of current through the torso of a person in 1.5 milliseconds. A, how much charge moves during this time, and B, how many electrons through the wires connected to the patient. So we're given a couple of things. So first, we are given the current, which equals 17A, and we're given the time, which T is equal to 1.5 milliseconds. So first, we're going to start off by converting 1.5 milliseconds to seconds. So it's going to be 1.5 times 10 to the -3, which in seconds is going to be equal to T equals 0.0015 seconds. So there's our time. Now we're going to move on to part B. Not part B. The second part, which is how much charge moves. So our current equation is the current is equal to Q over T. So now we're going to solve for Q. So to get Q by itself, we're going to multiply I to the other side. It's going to be, not I, the current, which is going to be I times T, and we're going to substitute the values. So Q is going to be equal to 17A times 0.0015 seconds. Sorry, my family is being really loud in the background. And our final answer is going to be equal to, let's do this calculation. Charge is equal to 0.0255. So that's our first answer. C. Moving on to part B, how many electrons pass through the wires? We're given, we have this first equation, which is N equals Q over E, where N is the number, why am I doing that color? N is equal to number of electrons. Q is equal to total charge. And E is equal to the charge of one electron, which is 1.602 to the -19. So now we're going to substitute those values. So N is going to be equal to Q, which we did in pink, 0.0255 over E, 1.602 times 19. calculate that down here, which gives us 1.5918 times 10 to the 17th. But we can round that down to 1.59 times 10. So that's going to be our final answer, and our units is going to be electrons. So that's our final answer. Okay, so I just wanted to make sure I added a picture to 2B's problem. I drew this beautiful AED, and what I'm going to be explaining is how this works. So basically we have our AED, we have our conventional current flowing from the defibrillator through the wires into the patient. So here are our patient's AED pads, and then we have our electrons flowing in the opposite direction back into the defibrillator. So yeah, I just wanted to make sure I added a picture in there. But yeah, this is our diagram of the question.